بسم الله الرحمن الرحيم رب زدني علما.
Now, there is a small concept we need to understand while implementing a GRE, like what we did in our case. We have configured the GRE tunnel here on the top of this. So we got a GRE header which is added, and your packet is routed based on this GRE header. That's something happens. And again, recently what I did, I also added an IPsec on this because I want to apply some security. So I'm looking to apply some kind of security so that all the traffic goes over the tunnel should be encrypted. So which means it also adds your IPsec header as well, which means additionally it is going to add an IPsec header as well. So if I'm using GRE with IPsec, it actually creates an overhead of adding the GRE header as well as your IPsec header to the actual data. So it's like you are encapsulating your packets 2 times. So this is your normal packet, and this normal packets added with GRE tunnel. And again, now this becomes your GRE tunnel, which means this part is like your GRE tunnel. And additionally to that, you also add some IPsec header. Because when the traffic is routed over the GRE tunnel, it's going to use the GRE encapsulation to tell where the packet starts, where it ends. So that GRE header will be used, which adds the IP new information. And also there will be a new IP information added also to the IPsec, because IPsec also works in a similar way. So there will be a new IP added on the IPsec, as well as there will be a new IP added on the GRE, which is like unnecessary, because when you're applying IPsec over GRE, basically you are just trying to add some additional unnecessary 4 bytes of GRE header, which will increase your bandwidth requirements as well as the overhead on the routers. So to overcome this, there are few fixes you can do. You can just fix few things to make it less overhead, or just to remove the options. So one thing what I can do is I can convert this GRE, because GRE default is a which mode? Generally the GRE, the default mode is a tunnel mode. So default is tunnel mode. So in the tunnel mode, it automatically adds a new IP header, and your packets will be routed based on this new IP header. So what I can do is I can convert this GRE, which is the default tunnel mode. I can say that GRE, I don't want you to add a new IP header. So just don't do it. Okay, there is no need for that, because already IPsec is adding a new IP header, which it does automatically. So you don't need to do that. So what I can do is I can convert this GRE into a transport mode. Now, basically, either you can convert the IPsec into transport mode. That is one solution, not GRE. Basically, we are converting the IPsec. The default mode is a tunnel mode. Either I can remove IPsec header information or GRE information. So there are 2 options you can do. So there's no need for both. So if you want to remove an IPsec information, then you can convert this into the transport mode. So I can convert the IPsec to run the transport mode so that it does not add the new IP information. So it goes as it is, which means it will be using GRE IP header in case if you remove the IPsec mode. So one option is I can use the IPsec transport mode, which will remove the IPsec new IP header. That's something it will do, because transport mode will use the same IP. It doesn't add the tunnel IPs. With IPsec I can do. The second solution is I can go with GRE, and I can say the GRE should use the other option here. One option here you can see I did this. You need to just change the transform set and change it to mode transfer. This is your first solution. So this basically removes this IP. So the tunnel mode will add IP, whereas a transport mode will not add the IP. So those things, and that is one solution. So let's quickly do this. Even you can use a native IPsec. Again, native IPsec, I'll quickly cover up that a little bit later. So what I'll do is I'll go ahead and make some changes to this as per my requirement. I'll change this one. So let's go to the CLI. And if you go ahead and verify the configurations here, show run section crypto to see your configurations. And you can see here, even though I did not define the mode, the default mode, it uses tunnel. But I'm going to change this to transport mode. So in the transport mode, it's going to use the payload encapsulation, which is based on the default. It's not going to add a new IP header. So once I do this, which means now it doesn't add the new IP header here. So it does not impact your communication. So if you try to see, still you do have an end-to-end communication between them. So it still uses the same, this one, because here we are actually removing the IP header. Still, it's going to use the GRE header. Again, the second solution, as I said, instead of GRE, you can use a native IPsec. Again, that's something I'll be covering a little bit with the static VTI concept, what exactly it is. But that's a kind of alternate solution you can also go with. You can just go with a native IPsec without GRE. So you can just remove the GRE encapsulation and use a native IPsec with tunnels. So if you try to see, there's no issue here. So if you see, the end-to-end reachability works fine. So these are some of the things you generally want to do. You really want to optimize your configurations. At the same time, you don't want any kind of additional unnecessary overhead. And that can be done with these solutions. We can simply go ahead and say that IPsec will be using transport mode, which basically says that do not add a new IP header, unnecessary 4 bytes overhead that can be removed by using this solution.